Okay, so welcome back. In this particular video, we are going to deal with a nice little indefinite integral. This video is presented to you a MATHeSYICS education. I, Akash Sarkar, is going to give you the nice little sum to do on your own, and then you're going to see the solution as well. Our motto is quality learning for all and for free, and our motto will only be succeeded if you help us by subscribing our channel. Let's begin. Today's integral is integral of e to the power x minus 1 by e to the power x plus 1 whole to the power half. Nice little integral you can understand, but this I want to make you something clear that you have to solve it on your own first. You must try it at least. So can you solve it? If you please try it on your own and pause the video and then see the solution to match it up. Now let's begin the solution. The n is missing, right? Sometimes it happens. Nothing to worry. Now let's begin. So our integral was e to the power x root over e to the power x minus 1 by e to the power x plus 1 dx, right? So let me make a substitution, very simple substitution, x equal to minus t. That will yield me dx equal to minus dt, right? Now this will yield me 1 minus e to the power t by 1 plus e to the power t minus dt, right? Because in the denominator e to the power t and e to the power t will get cancelled. You can understand, I hope. Now let me change the pen again because there is another substitution that is going to happen at this stage. Now I will bring the minus sign out and write it something like this. Now let me take t is equal to log p such that dt is nothing but dp by p, right? If I make this substitution, what advantage I am going to get is that I am going to get rid of the exponential and reduce it to some algebraic rational terms. Okay, so see it. Integral of 1 minus e to the power t will be reduced to 1 minus e to the power log p to the base e, which will reduce to 1 minus p by 1 plus p, and there will be a dp by p outside to compensate for the differential dt. The minus sign is also there at the outside of the integral. Now let me make it very clear to you at this point that I have used this relation e to the power log p to the base e is equal to p. Okay, I have used this. Now let me get back to the problem. Now the integral reduces to 1 minus p by 1 plus p dp by p, right? This particular form is reminding me of that equation or expression, you can say 1 minus cos theta by 1 plus cos theta. That sort of a thing is remembering me. Now if I put p is equal to cos theta, then dp will give me minus sin theta d theta. Let me substitute that. If I substitute that, I will get minus root over 1 minus cos theta 1 plus cos theta. In place of dp I will write minus sin theta divided by p. What is p? Cos theta. And in place of this is d theta, right? So this is our little integral. See how it is simplifying. Till now I am trying to simplify as much as possible. Let's do another. See, this minus sign and this minus sign gets cancelled, so we are left with this integral. We are left with a very simple integral, something like this. See, 1 minus cos theta divided by 1 plus cos theta will give us 2 sin square theta by 2 divided by 2 cos square theta by 2. 2 will get cancelled and we will be left with tan square theta by 2. and since there is a square root, so root over tan square theta by 2 will give us tan theta by 2. So this will be tan theta by 2 into tan theta d theta. Now in place of tan theta by 2, I can write sin theta by 2 divided by cos theta by 2. Here I can write sin theta by cos theta, but again sin theta can be decomposed into 2 sin theta by 2 into cos theta by 2. Why not use it? Because I can easily see there is a bit of cancellation going on. Right? If I reduce it, see cos theta by 2 and cos theta by 2 will get cancelled. That's why I chose to use this expression. Now 2 sin square theta by 2, and in denominator there is cos theta. Now cos theta can again be decomposed into 1 minus 2 sin square theta by 2. 1 minus 2 sin square theta by 2. Right? I think it is clear to you. Now this can further be decomposed if I make a simple substitution. Let me do it in this particular line only. Let me add a plus 1 and deduct a minus 1 and then write d theta. Then you can see that 2 sin squared theta minus 1 will cancel itself with the numerator and the denominator, and it will come out as minus d theta. And in the denominator you can understand there is still, they see 1 minus 2 sin squared theta by 2 in the denominator, and in the numerator it is 1. So let me write it for you. D theta divided by 1 minus 2 sin square theta by 2. Right? So this is in the denominator. But what is this? This is cos theta. This is cos theta. Right? If this is cos theta, then you can understand I can decompose it into, let me draw a line so that you don't misunderstand. Minus, here is a minus sign. Why? Because there is plus 1. Right? This plus 1 divided by 1 minus 2 sin square theta by 2 will be coming out, and 2 sin square theta minus 1 will be yielding minus d theta. Now theta plus sec theta d theta. Now this theta minus theta will be yielding us log mod sec theta minus tan theta, sec theta plus tan theta plus a constant of integration. Right? You know sec theta, if you multiply the denominator, integral of sec theta d theta is a standard integral. I hope you don't need to see it more than once. And now in place of theta, what I have substituted, I will again back substitute these things. First I will do, let me write at the top because I am running out of space in this particular slide. Okay, now here you can see that in place of theta I can write minus cos inverse p. Okay, in place of the minus theta I can write minus cos inverse p, and plus log sec theta. Sec theta is inverse of cos theta, so it will be 1 by p plus there will be a tan theta. Now what is tan theta? It is simply sin theta by cos theta. So there will be root over 1 minus p square divided by p. Okay, plus constant of integration. Okay, 1 by p plus root over 1 minus p square by p plus c. Okay, now in place of p I will write, see, e to the log p, t is equal to log p, so p is equal to e to the power t. Right? So let me write it over here. And also let us do it at once. In place of t, I will write this minus sign will go over here, and t is equal to minus x. So let us put it at once. In place of p, we will write e to the power t, which is nothing but e to the power minus x. Okay. So this is the scenario. Okay. Now e to the power minus x will be put at here. Log mod 1 by p is nothing but 1 by e to the power minus x, which is e to the power x, plus root over 1 minus e to the power minus 2x divided by e to the power minus x. See, this is the mod sign, okay, plus the constant of integration. So this is our final answer. This is our final answer. Hopefully the solution is very much clear to you. If not, take a screenshot, write it down and try to understand. I have tried my level best to make you understand. There are 2 to 3 substitutions. That's why I have chosen this problem. Thanks for watching. I have told you previously also, again I am telling, please to subscribe our channel. It's important because we are very young and we are trying to provide as much as we can at our age. Sharing our channel more and more will be a heavenly job for you, and watching full hour videos is like making your life comfortable. I hope you can understand from the quality of the videos that we are making. Hopefully you are not that much, means you can understand what I'm trying to say.